Okay, so welcome everyone again. This chapter is chapter 8, and we are going to have an overview of the essential packages for machine learning. And obviously we are using R. And but so I foresee an improvement of this book within Python framework, and so that is going to be in the near future. So this is the chapter, okay, and as you can see, the contents of this chapter are like a bit of introduction of the R packages, and a list, grouping list of the essential R packages for machine learning, and then an application, okay, of selected frameworks within our packages and meta packages that are found useful for particular use cases. And then finally, just I don't think we are going to have any chance to have the time to reach this this last paragraph, but that's for you if you are interested in just a way to find packages within the find our packages, and there is a bit like snippets of code that allows you to find packages with keywords. Okay, so what's I really like it. So I started with Python, just a bit of an overview of coding environment that we are using very frequently and are very useful for dealing with our data and things. I started with approaching Python, okay, but then you know, the R community is very friendly and things. So the end of the story, I found very straightforward to learn and improve my R skills. And so I left Python a bit behind, but so the R R is a functional language, so that means that it's rich in functions, and it does provide you know, lots of packages. These packages can come within group of packages, and this group of packages are defined as meta packages. Okay, so you for example, just to give you a very basic, the tidyverse meta package, okay, it's just transformed the R language within different way to use the R code. Okay, so it says defined as a human, a bit more like human readable. But if we do a step back and think about just a base R, okay, the base R, it's like thinking outside of the library boxes. So base R is all that comes with a fresh installation of R, and you can use that. You can absolutely perform your analysis with base R. Okay, obviously, what's you know, tons of data scientists and professionals using this language have improved the language, providing functions wrapped up within our packages. Okay, so I'm not reading everything out, but you know, here it's like a bit of introduction of the universe of R, what is comes inside. But here it comes with a bit of trust. So you have fantastic functions, fantastic packages. Do you trust them? Big question mark. So sometimes you might question yourself and say, is that going, so it's doing the things that I wanted, that, you know? And so it's good practice to know what's happened outside the library boxes. to be able to, just in case you want to see what is happening when you are using an R package and a function within other packages, and trust the output of the use of these tools that are built up upon the base R framework. Okay, so within time, many packages and meta packages have been built, and we are talking about machine learning. Obviously, the boundaries within AI, artificial intelligence, and machine learning are always becoming like a bit like thinner, such as so machine learning is part of AI, and what is the key things is that it's parameters calibrations. Okay, parameter calibration. What are the meta packages that I selected? I'm not talking about like this way because it's everything updating very fast. So this can become very out of so like obsolete. It can happen. Okay, so I mentioned these frameworks such as tidy models, Cohort, which is being built before tidy models. So such as tidy models can, in some senses, overcome Cohort, but it is not because there are differences that sometimes you might want just to choose Cohort instead of tidy models. And then I've chosen MLR3. So these are not exhaustive. There's more, but for now, let's focus on this. So tidy models, it's a language, such as the tidyverse. Huh? Okay, what tidy models does is basically transforming the way of modeling, providing you a way to chain different type of models and then be able to evaluate more than one model in one go, and so on and so forth. Cohort as well, but it's like a bit like the precursor of tidy models. So it is useful sometimes to do something straightforward, avoiding like packages, conflicts and things. But then at the end, I've chosen MLR3. MLR3 is a fascinating meta package. It provides different packages within its framework. And it's very interesting even to see, because it's allowed you to understand machine learning, because it talks about the learner. And we are going to have a very quick touch of what's happening inside MLR3. I suggest you to, if you are interested in going deep on those things, to have a look at that. There is even a book. It can, sometimes it can seems like a bit difficult, but when you, I've shown you here just a very simple case study. It can expand for you to use the most incredible things within this meta package, as well as the others, but it's very interesting. So let's have a look at this. These are the meta packages. Okay, within these meta packages, you use functions. Okay, and you might want to use extra packages, extra R packages. These are focus for example, for this on specific type of models, such as random forest, XGBoost, GlimNet, and so on, neural network, and so on and so forth. So you might have some of this model function within base R, so outside the library boxes, but as well, there's many packages built focusing on a specific type of model, as I mentioned just earlier. And so here I've listed my favorites. And as you can see, There's many, okay, that's all very interesting and useful. And what I really like to do, for example, is putting some of them inside a box, run over all of them and see what it performed best. Okay, so this is science research and things. When you work on some data, you may want to just use CrimNet for some type of data and nothing else, because you know that works. But in another condition, you might want to try different things and see what is happening. And so this meta packages allows you to use more than one packages and see what's happening. Then what I really like is this H2O. And this is as well a framework, a machine learning framework. And it's that comes with JavaScript underneath. So and it performs very well as well. So, and then there is Keras. Okay, Keras is another world. It's another universe of things. That it's a translation of what is done in Python and things into R, and it works very well, and it as well very interesting. So these are for list of like type of models. Then I've grouped it this way. It has been difficult in some senses to understand and divide meta packages within engines and then specify time series analysis. I'm not sure if that's entirely straightforward to, but within my mind, I wanted to group those things to have like clear the type of analysis that you are that you can do. They might be different. So if you do time series analysis, you might have different type of packages. If you do Bayesian analysis, you have other packages, and we will see these things throughout the rest of the book. And then here are specialized tools, especially for spatial analysis. So now they are all those ones that I use in the various case studies I mentioned in the following chapters, and they are all very useful. I think that to have an overview of what's happening with these tools allows you to be able to choose which one is the best for your analysis. So let's have a look at, for example, here is a case study, okay? And here I want to show to you, I don't know if you have an idea what's happening within tidy models and Caret and things. There's other, we already have seen examples, an example of that. Here I like to have a look at MLR3 and how to use that. And this, I jump into R. Okay, so let me restart the session. Okay, let's go visual. Change this thing, I don't know. Looks like it doesn't. I'm backing up the session. Okay. Takes a bit. Okay, so this is the chapter. Okay. As in this chapter, So I want to share that things again. No, I don't, doesn't. So as you can see in this chapter, we use MLR3, H2O, and KIRAS. So to just a quick touch on the difficulties sometimes when you use this different tools within a Cohort document. Not that difficult, but you know, they may arise conflicts. Okay, when you run a tool and then you jump on the other one, and some packages are that they don't know what to use, and so the turnaround I found useful was to so basically detach all the previous packages and then load the new ones again. Okay, so let me see, but if I go on source and we see that the application sample will M3. Okay. And okay, so we load the tidyverse and the book package for using the infectious diseases data set. If I run this, okay, we can see that in this data set we have the cause name, the location, cause name, deaths, DALIs, ELDs, etc. Okay, so we filter dengue as a cause of infectious diseases, and then we have a look where what are the locations available. Then what we do a bit of like data manipulation, okay, and make a plot to see, okay, how the year of life lost, year lived with disabilities and DALIs due to dengue. This is basically from 1980 to 2021. And we see that the dengue affect this 5 countries differently along the time, okay? So while some they are very close to zero, others reach like within the 90s and the 2000s, like a nice peak. But so we like to have a look at these trend and locations, and what we do is basically just to see how this model performs within predicting the future. Okay, so what I did is to select just 26 years. So from the 1990s to 2016, and then leave the 2017 to 2021 as a test to test the models. Okay, so make a selection to be the years less and equal than 2016, and select just these 2 locations. It's Sweeney, sorry about the pronunciation, and Lesotho, because they are, you know, the 2 with a nice peak and outcome. So here we can see that this is the data set where we are using MLR3. We have the prevalence and the incidence. So all the things that we are interested. What we are going to do is basically use this meta package. This meta package, you'll find in the book the link to the documentation and things. This package, this meta package provides other packages. So the learners, the beats, the MLRT verse and data table. So that these are all, you must have to use it. Okay, so what's gonna happen here is that we use a GlimNet model and a XGBoost for this data. Okay, we know I'm now mentioned in the previous chapters a bit of like what are the models that are not linear. Okay, within these models, there are these other variants. Okay, they are adjustments of the base GLM model. And so we are going to use this. You need to install and load this bunch of packages. And sometimes, in case you don't have, you need to have XGBoost package as well. Okay, so let's see. Let's run this. As you can see now, there's a bit of like explanation and things, that all the things that you are. Okay, we are not spending time on these things. Okay, what MLR3 require you, and just as the same as the theory of machine learning, require you to define a task. Okay. Okay. What is your task in this case? To identify, okay, thingy within time, and so you, within this task, you identify the ID, the backend, and the target. So where you starting from and where you are going to, and what you want to achieve. So the target. So the backend is the data that will be used for training the model, and the task is the interface between data and the learners. Okay, but it's all good, because the best way to see how it performs and what is happening. So we do a bit of like pre-processing, and we use this task regression. Okay, so I haven't mentioned it too much, just jump into the how to use the thing. Okay, you within MLR3, you have different type of tasks that you can use. In this case, we use task regression. And this is the syntax to assign a new task. Okay, you can. Okay, I'm not going into the documentation, because otherwise we don't have time to do the other things. But it's quite straightforward if you search within MLR3 and ask AI or things, what are other available tasks that you can choose from. In this case, we use task regression, and we assign a new task. Our ID, so we are focusing on DALIs, the matrix, and the backend is the DALI dingy, and we assign this as a name. Okay, this is a name that is assigned. But where is our data? This is the data. So as you can see, we don't have that within our data. It's just a name that is given to that the output will be assigned. It's the name of the vector. Okay, that it will come out, and then the target is the DALI. So this is our task. If we run that, okay, and have a look at the task, this is what, so the summary of what's happened, basically. This is the target. These are the 7 features that are used in the target. If we want to see, we can see, for example, let me use that for a minute. Okay, use task and the $sign. We see that we have different options that we can use. Okay, that's many options that we can use. And so here we do task data. As you can see, there's the data that we have, but there is a specification, because then what the model does is just going to search for the vector with a name, specific name that he's searching for a specific location ID and things. And we select just to some information to have an idea. It's our data. This is going to be the data used inside the model. And so we have created a task this way. Okay, so this is the first step. Then here we build 2 models, a GlimNet and a XGBoost. We call it, this is general. If you see MLR3 documentation, in general, it's this is a learner. Okay, machine learning theory. You have a task, then you have a learner. The learner is the model that learns through running the functions many times, assessing the parameters and things. So that's so this is generally in MLR3 called learner, and then you specify the type of model. It's a cross validation GlimNet. Okay, that means specific type of model. Okay, and so this is the learner. Okay, so this learner for the CV GlimNet allows you for some options, and as you can see, we have specified an alpha and a spline. That's when we do polynomials. Okay, so the polynomials in this case will have a power of 0.1. It's estimate. Within the regression XGBoost, there are other options specified. If you use tidy models, for example, and you set up different models, you as well have the different parameters that you can assess and a specification too. So even here, you have specific options for different type of models and rounds, the max depth, and the eta. Okay, for the XGBoost type of model. So here requires a bit of knowledge of modelings, and maybe you need to jump into documentation and have a look. But you might just have your model know which one to use, and you just know that you can use this function learner, you assign the task, and then use this function learner with the type of model. Have a look at the documentation and specify the options. Okay, so here are our 2 model specifications. let's run these two. Let's have a look at one and see that just, you know, specific elastic neck regularization and things. And then we do a resampling and we set a benchmark. So here, I like this MLR3 because it's really following the theory. Okay, you have task, learner, model specification, then you have you said the resampling things, and then specify the benchmark. Benchmark is at the boundaries of your model specification. So you frame the model not going a bit over. Okay, and so the benchmark reads the task is this task, the learner are these two, and the resampling is the resampling. Okay, these are, it's like the workflow within tidy model. And so this is the design. And we can see specification, it's all inside the box and things. Then we run the benchmark, and the benchmark, as you go, this is the benchmark grid, and this is the benchmark. Inside the benchmark, it's always good practice to set the seed for reproducibility. And so you have this benchmark function where you put the design inside. The design is this one here. Okay, so we run this. It's very fast. Obviously, we haven't used many models, just 2 models, and not specify that much. So we can see that works very well. It throws an output, and here we can see that the task ID is the DALI, the learners are these 2. We have some resampling things, the number of iteration, errors, zero, and things. Okay, so this is our benchmark. Okay, if we see in here, ask for the task. Even here, if we do $, we have various things that we can choose from. And again, and again, okay, here, if we have a look at the score, okay, just have a look at this score. Okay, you see that there are some information like the number of iterations and the mean square error. Okay, so we can like select, this is a base R way to select the learner ID, the task ID, the iteration, and the state something. We do that. We can see now we have just selected some vectors. Okay, so we have the model has already run, and with the cross validation of 5, we have 2 models. Okay, GlimNet run 5 times. And this is the mean square error for each time. XGBoost run 5 times, and the mean square error. Okay, so I do a visualization and see that the GlimNet for this is my mean absolute error, but the residual the RMSE, as you can see, the GlimNet is less you know, there is less variation than the XG boost, and as well of for the MAE, so the mean absolute error. So this has some meaning within choosing one of the two models, and these are, we can even use this function MSRS measure to extract, tell the benchmark to extract the measures. Okay, if we have a look at this aggregate output, okay, so we can see that we have the two RMC and mean absolute error for the two models, and then we use this into the resample result. Even this matrix, the aggregation of this matrix allows you to do some selection. So in this case, we use the resample result. If we, okay, just use this one for XG boost, and the other one for GlimNet. Okay, this is model 1, and this is model 2. We can run these two. Now let's comment out these two, because otherwise I run them again, and then we can just build up a data frame with the data to plot the output of these models. Okay, this is the data. Okay, so this is the truth. So our data, our starting point. This is the response, the output of the model. The learner is the type of model, a GlimNet or XG boost. As you can see, if you don't have a background of this, you need to spend a bit of time, but then you can even just apply this and see if it's what is the output, basically. Okay, so this is the data. Now you have the truth and the response very clear. As you can see, the truth are the DALIs. You see that it's exactly the same, but it has created a vector with a name truth to be used within the autoplot functions and things. So it search for specific vector with a specific name, basically. But as you can see, is the truth are the DALIs, and the response are the output of the model application. We can have a little like visualization and see. As you have seen, it's impossible to do that but faster than this. So we need to spend a bit of time on those things. So we might want to, if you, I don't know if you are interested, if you want, we can continue with the other. Let me stop share this thing, go to the chapter. Can even do that. Yes. Okay, so this is the output of the so we did this two. This is the output of the two models. As you can see, GlimNet, it's less, there is less variation. Okay, so we have seen this with it, but it's not said that that is going to be the perfect model for this data. So it might outperform. So that means that it might be overfitting the data. So it's very good with this data, but then when you apply even just a little modification of the data, it might not work very well as well. So what we want is a model that it will be able to catch very closer trend to reality, and this is might be sacrificing, obtained by sacrificing. So you might want to choose not a perfect model for allowing this to be good with new data in substance. So the XGBoost in this case, as you can see, what does is allows you with a bit of variation, but it might be good with future other data. Okay, so and then what we do is another visualization, and where we have the continuous line, the GlimNet, the dashed line, the XGBoost, and the dots are the truth. Okay, so it's now up to you to choose between this various type of model output, and obviously this is a quite long time of this just few data, and so you see that Dingy is quite disappeared. You never know what's going to happen in the future. So this is just MLR3. You can perform the same things with tidy models, with Cohort, with whatever you like. Okay, so now we don't have time to go any further on because it's quite, you know, everything. But you can do it yourself, or we can do another week on this chapter. We have a look at H2O and Kiras. If you want to have an introduction of this things, it's up to you, you know, to decide. I see that, you know, just sometimes it's not that straightforward, so it requires an extra focus on documentation of each package to be able to apply these techniques. But what I wanted to, the purpose of this is to show you machine learning. So even if you have different frameworks, all that happens inside is the same. You specify an object, so that task, and then you have some models which are the learners that learn calibrating parameters. When you parameters are calibrated, you check for the metrics, and then you know, do some visualization to see the out. Select your the best model, and so I'll stop sharing because I think it's that it's gonna be too much. So I stop sharing and stop the session here for today.